Alright, welcome to this video where I am going to talk about how we can leverage Desmos to 1. Identify the slope of an equation, and 2. Identify the y-intercept of the equation, and then 3. Use this tool and this technology to help answer some of these questions. So right off the bat we're looking at this particular example and it's saying what is the rate, or the function represents, the function represented in the table below follows a linear pattern. So that tells me right off the bat that this is going to be a linear equation. So we can use some rules here. So if I look at just the relationship of these x values, I know it's going to be increasing by 2, increasing by 2. And then here we're increasing by 10, increasing by 10. So we could use some inductive reasoning here to say, okay, it's increasing by 10, and x is increasing by 2, y is increasing by 10. So if I look at the rise over the run, I can say, I can learn how to write rise over run. I've got 10 over 2 or 5. Okay? My pen's not acting right, so bear with me here. So I can tell you that the rate of change is going to be 5. Okay? Now, we've also been talking about how we can leverage the point-slope form to write the equation of a line using one point and the slope. Now, since we've already found the rate of change, we can sub that in for m, because rate of change is going to be the equivalent, to the slope. Now, we have 3 coordinate pairs here. We only need 1. So I'm going to pick the smallest x value. So what we're going to do here is we can say x1 is going to be equal to 2, because that's the x coordinate in the first row, and we got y1 is equal to 14. Okay? So let's clean this up a little bit. I'll give you a minute to jot this down as well. Okay. So what we can do is we can take this y minus 14, set that equal to 5 times x minus 2. Now anytime you set up point-slope form, the same process happens next. After you set it up, you're going to distribute the slope to each of those terms. So we have y minus 14 is equal to 5 times x is 5x minus 5 times 2, which is 10. Now the last thing we want to do is we want to add 14 to both sides of the equal sign, just so we can isolate the y variable. And we have this equation right here. Y is equal to 5x plus 4. Now what we can do is we can check this work using technology, and we can go over to Desmos.com. So if you're not familiar with Desmos.com, definitely check that out. So if we look here, our table is 2, 4, 6 in the x, and we've got 14, 24, 34 in the y. We've got this all set up. Now, once you've built out the table, you want to make sure you're looking at the columns here and making sure that it's labeled x1 and y1. Because if it was labeled something like x2, y2, it's going to change the whole approach that we take down below. I'm going to change these back to x1, y1. So we know that the slope-intercept formula is y equals mx plus b. So the way that we can do linear regression in Desmos is we're going to take a very similar model, but instead of y, we're going to have y1. Now we're going to do a little squiggly line, and then we're going to choose x1. And if you'll notice, this graph goes directly through those 2 points. Now the cool thing that I want to draw your attention to here are these 2 parameters right here. So they tell us that m is equal to 5 and b is equal to 4. So we can say y is equal to 5x plus 4. Now if that looks pretty familiar to you, you should be saying, okay, that does make a whole lot of sense, because that's everything that we did right over here. So what I also want to do is I want to take this equation, y is equal, well, another thing we can do is if we have a decimal, we can type in m, and it's going to give us our slope here, and plug in our b. If it was a decimal, there would be an option on the left-hand side here that would allow Desmos to convert that decimal to a fraction, but we don't need to do that right now because we have integer values for our slope and our y-intercept. Okay. So the next thing we want to do is we want to create a table, because the last question here says what is f of 7? So this function notation essentially says, what is y when x is equal to 7? So what we can do is we can click here and go to this gear function and then convert that to a table. If we go back here to verify, we want f of x when x is 7. So we have power to change all of these. So once we've established our equation, we've got our table, we can change our x value to 7, and then it's going to give you 39, and that's going to be our y value, or our y value when x is 7, so 39. And then we can go up here, we're going to say that that is 5. Okay? So when we're doing this work, we want to make sure that we have our table set up properly. So we can do the same thing now that we have our table set up in Desmos. So we can change this to 4, -4, and then we can change this to whatever that second coordinate is, which is -4, 2. -4, 2. So I'm going to get rid of this because it's old and it doesn't matter to us anymore. So here we have our new equation going through those 2 points. This is a perfect example where we can take our m, and it's going to be -0.75. If we wanted to convert that back to a fraction, you would click this fraction icon here, and then it converts it to -3/4. So y is equal to -3/4 x minus 1. So we can then take these parameters given to us from Desmos to write their equation, and you'll see that these equations perfectly overlap one another. I can change the color here just to get a different perspective. So that's going to be red. If I deselect it, the black one is right underneath. So hopefully this was helpful. Make sure you have this syntax y1 squiggly m times x1 plus b in your notes as you're doing this work, because that is going to be the key to the kingdom and how you're going to be able to use Desmos to do linear regression models to help you find the slope and the y-intercept, which will ultimately help you build your equation.